Hello everyone and welcome to this video. In the previous video we have talked about the human and machines. We compared them together. We've talked about the ability of each of them. So in this lesson we're going to talk about how to think like a machine. So let's check the overview of this lesson. In this lesson we're going to talk about the computational thinking. We're going to talk about tiny switches and binary code, autonomous decision, and logical operators. So the first subject is computational thinking. In the previous lesson, we've learned that computers are really good at performing tiny, simple operations very fast. Complex modern tasks like video streaming or online banking transactions can be broken down into these simple calculations. In this lesson, we'll learn how to think like a computer to bring you one step closer to becoming a human-machine hybrid. So, tiny switches. What is the tiny switches? Electronic circuits inside computers encode information, encapsulate the information in millions of tiny switches. The state of these switches is on or off. So here, this switch is on and this switch is here off. So there is tons of switches that can be on or off, and according to the information, the state of these switches will change. These switches can be in two different states or position, on or off. By turning switches on and off, we change the information stored in a computer. So being on or off makes changes on the information which are stored in a computer. The next subject is binary code. Computers use binary code to represent information. Binary means that there are only two possibilities for the state of a switch. To make things simpler, numbers are used to represent the off or on state of a switch. So here, as you can see, this switch is on and the number is 1. Here, this switch is off and the number is 0. And also here, this switch is off and the number is 0. And here, the switch is on and number is 1. So basically, if the switch is on, the number is 1. And if the switch is off, the number is 0. Yeah. Information like numbers, text, characters, images, and videos can all be represented by binary code. It's like a language which basically has two letters. It's like speaking in a language that only has two phonemes. For instance, letter capital A is in binary 0, 1, 0, 0, 0, 0, 0, 1. Or character at sign is this number in binary. So you don't need to understand binary code to become a coder. And the next topic is about autonomous decisions. Electronic circuits can perform billions of tiny operations very fast. Besides simple addition, subtraction, and multiplication, computers can also perform comparison operations. Comparison operations are needed for machines to make autonomous decisions. There are only two possibilities as the result of a comparison operation: true or false, which means that true is 1, false is 0. Let's have a closer look at some comparison operators with some examples. Is 5 less than 9? If this statement is true, the answer will be true, or the answer is 1 in binary. And if this answer is false, the answer will be false in logical operators or will be 0 in the binary code. So we write it like this: 5 is less than 9 is equal to true. So this statement is true. And is 5 greater than 9? We write it like this: 5 greater than 9. This statement is false, so we write false, or in binary we write 0. True and false values can be stored as on or off states of switches. True is equivalent to 1 and false is equivalent to 0. So let's check the logical operators. Logical operators are another type of tiny calculations that machines can do faster and more accurately than humans. Logical operations are needed for machines to evaluate different scenarios. The AND logical operation takes the state of two switches, A and B, and results C in true only when both inputs are true at the same time. For example, here we have two inputs, input A and input B. The input A and B both are false, so the output C will be false. Here, the input A is false and the input B is true, so also here the output C will be false. Why? Because one of them is false. So here A is true and B is false, and also here it returns false value. And the fourth state, A is true, B is also true, and it returns a true value or true output. So in AND logical operator, both inputs should be true if it returns true, and the other three states it will return a false value. The OR logical operation takes two inputs A and B and results C in true when at least one of the inputs is true. Here the A is false, B is also false, so it results false because both of them are false. Here A is false, B is true, and it returns true because the condition was that at least one of them should be true. Here it is true, B is true here, and it returns a true value. And here A is true and B is false, also it returns a true value. And the fourth state, A and B, both of them are true, and obviously the result will be true. So the OR operation is different than AND operation. In AND operator should be both of the inputs true in order to generate a true output. But in OR operator, if one of the outputs is true, it will generate a true value. And if both of them are false, it will generate a false value. So this is the end of this video. Let's check the lesson takeaways. In this video, we have talked that computers store and operate with information in the form of zeros and ones. This is known as binary code. And the second topic that we have talked about is that computers can perform comparison and logical operations very fast and accurately. This helps machines make autonomous decisions. And the last one is that true and false values from comparison and logical operations can be stored as ones and zeros. So this is the end of the video. As always, make the most of your time, and bye for now.